Hey everyone, I'm Devon. I work at Adobe on our Spectrum design system, and today I'm here to talk about building adaptive UIs and accessible components for the web. So I'm going to tell a story that maybe some of you can relate to. A few years ago, I was working on a product team, and we got some new design requirements. Our new design system was just starting, and since we were building a brand new product from the ground up, we were one of the first teams to adopt it. The problem was there was no existing implementation of the components, and at the time, there was no team whose job it was to build them. So we had to implement them ourselves as we built out our product. We looked around for a library that might be able to help us. There are a lot of open source component libraries out there, and we even had a couple internal ones, but they were all pretty tied to a specific design and styling methodology. So we knew we needed to do a bunch of work to build our own set of components for the new design system. We started adapting the existing internal components for the new design and implementing a ton of new ones as well. Things were going pretty well, and we made good progress on our product. React seriously made building these components easier than ever. We could bust out a pretty good component in a day or two, and it was honestly really exciting and fun to build all this. But as teams across Adobe adopted our library, we started getting lots of bug reports for an increasingly wide variety of devices and scenarios, and feature requests for many things we hadn't considered before. We learned we needed to deal with edge cases in certain browsers. We had to support users from around the world that spoke different languages and read dates and numbers in different formats. We found out that people actually used our products on mobile, so there were small devices and touchscreens to consider. And then there was accessibility. People needed to be able to use our apps without using a mouse or touchscreen at all, through keyboards and screen readers. And as you can imagine, all this started to pile up over time. We were lucky to receive contributions for a lot of these features from many teams around the company, but since we hadn't designed the components to support all of this from the start, it really started to feel hard to make changes to components without breaking things. The APIs weren't well designed or very cohesive across components. There were many different ways of doing things. Features had been hacked on to fit the existing architecture, and there were still lots of bugs and edge cases that we really didn't have a good way to solve. You might say we had discovered technical debt. At this point, we started to wonder what other companies were doing. We looked around at open source libraries again, and while there had been some improvement since we started, we really didn't feel like there was a library that we could easily adapt to fit our needs. And every other company seemed to be doing the same thing. They all had their own unique set of components that they were developing from scratch, all with varying levels of support for things like accessibility and cross-device interactions, and they all had their own styling baked in. Why is this? Why does every company need to invest millions of dollars to pay a team of developers to build the same components over and over and over again that every other company is also building? And why isn't this solved in the web platform? After all, native apps don't need to do any of this. They get to use a set of really high quality pre-built components to build their apps. So looking into this more, we realized that it's because the web is actually quite unique as a platform. First, it runs everywhere, on desktop, mobile, TVs, cars, even refrigerators. Native apps only need to support maybe one of these or two, at best, and they need to support one or two interaction models, not all of them. And web apps also don't really have an intrinsic aesthetic, whereas native apps often have stronger conventions about how UIs look and behave. Each web app has its own unique design, and this leads to designers getting really creative and styling every component to match the company brand. Since the web has so few built-in UI components, and those that do exist are so hard to style, it leads to every app needing to re-implement most components from scratch. We just have divs and low-level elements like mouse and touch events, nothing like the high-level gestures and abstractions across interaction models that native developers have. And since we are rebuilding everything from scratch using rectangles, we don't get any accessibility for free either. As we found out, it's really challenging to get all of this right, and many companies and teams simply don't have the time or resources to do it properly. And unfortunately, this leads to many web apps having subpar accessibility and interactions across various devices and contributes to the perception that native apps are higher quality. But all this leads to the idea of adaptive UI. That's the idea that components can adapt to their environment. For example, components can be responsive and adapt to different screen sizes. They can change their appearance based on light or dark mode. They can respond differently when interacted with in different ways, for example, with a mouse or touchscreen. On touch devices, you might want larger hit targets, so you might see larger size components. Accessibility support is related to interactions as well, just another way that users can interact with your app in addition to mouse and touch. And finally, components can change depending on what region of the world they're in. For example, translating strings and mirroring in right-to-left languages. Let me go through an example of one of our components to show you some of these features. This is a custom select dropdown. We needed to support more advanced options with icons, multiple lines of text, and our own custom design, so that meant we couldn't use a native select element. At first, this didn't seem too hard, just needed to wire up a button and a UL element with some list items and some CSS, and voila! Unfortunately, it didn't turn out to be so easy. For example, we needed to support full keyboard interactions for accessibility. You can tab to the dropdown and open it by pressing the Enter or Space keys. The arrow keys can be used to navigate between the options, along with page up, page down, home and end, etc. And the Enter and Space keys can be used to select an option. And if you just want to dismiss the menu, you can use the Escape key. Then we need to support internationalization, including right-to-left languages like Arabic and Hebrew. In these languages, the entire component is mirrored, so the text is on the right and the chevron and checkmark icons are on the left. There's also type-ahead support. For example, in an address form, you can tab to the state dropdown and start typing to your state to select it without opening the menu at all. You can also do this inside the menu to jump to an item quickly in a long list without scrolling. This is often overlooked in custom select components I've seen, but an important one for keyboard users and even just for power users. I often use this feature myself when filling out forms and miss it when it's not there. Another feature that's often missing is integration with browser-native autofill. It's really annoying when you autofill a form and then you have to go back and manually enter your state and country because the developer didn't use a native select. There's no JavaScript event for autofill, unfortunately, but you can render a hidden native select and handle its onChange event to capture it. On mobile, screen space is really limited, so it would be really hard to use a drop-down menu. So the popover is replaced by a tray, which allows a bigger area for the users to scroll. We also ensure that users can use the next and previous buttons in the software keyboard to navigate through the form, which is another thing that's often missing from other custom select implementations out there. And finally, there's screen readers. If you thought dealing with screen readers on desktop was hard, wait till you have to deal with mobile screen readers. Since there's no physical keyboard, you navigate through the options with gestures on screen, like swiping left and right. This is possible due to semantic information exposed to the screen reader by ARIA. But what if you want to close the menu without selecting something? It's impossible because there's no escape key to press. So we had to add some hidden buttons to the start and end of the list so screen reader users can navigate there and press the button to close the list. This is definitely something we had never come across before in other implementations, and it's a good example of the kind of things we need to deal with when re-implementing components from scratch that need to support so many different devices. So listen now as we navigate around the menu with the screen reader.
To state, pop-up button, list box pop-up. Double tap to Alabama, list start. Alaska, Arizona, Arkansas, California. State California. Pop-up button. List box pop-up. Double tap to State. Arkansas. Arizona. Alaska. Alabama. Dismiss. Button. State California. Pop-up button. List box pop-up.
So with all those features in mind, we started considering how we'd rebuild our design system from the ground up, knowing everything we know now. It seemed like there should be a way to reuse most of the behavior, accessibility, and interactions across companies and design systems. This was exactly what we were looking for when we started building our component library. After all, a button is still a button even if it looks a little different, right? The ARIA spec even describes how all this should work. The actual behavioral differences between design systems are relatively minor. It's just the styling that's different. So what if we built that and shared our knowledge with the community? So we spent a year and a half doing just that, and I'm really excited to announce a library called REACT-ARIA today. REACT-ARIA is built as a part of Spectrum, Adobe's design system. It provides accessible UI primitives for the web. It's completely abstracted away from our design system and provides no rendering at all, just behavior and accessibility. It supports mouse, touch, keyboard, and screen reader interactions, which have been tested across a wide variety of devices, platforms, and browsers. It's internationalized into over 30 languages, including support for right-to-left mirroring and interactions. It's built on the ARIA authoring practices, which is a companion document to the ARIA spec published by the W3C that describes how many common UI components should behave in terms of ARIA semantics and keyboard interactions. And critically, since it provides no rendering at all, it's fully customizable and stylable for your own design system. So let's look at how this works. In order to build this, we split each component in our architecture into 3 parts: state, behavior, and the rendered component. Not all components have all 3 parts. For example, some components don't have state, so components have the pieces that make sense for their use case. And of course, all of this is powered by React hooks. At the bottom, we have the state hook. This is cross-platform. It can work on the web, on React Native, or other view systems, and makes no assumptions about the view system it's running on. It also has no theme or design system specific logic in it. It's implemented as a hook that just returns an interface for reading and updating component state. Not all components have a state hook, as I mentioned, mostly just ones that the user can interact with, rather than read-only components. In the middle, we have the behavior hook. This hook is platform specific and depends on the platform API, for example, the DOM or React Native. But it still has no theme or design system specific logic in it though. It implements event handling, accessibility, internationalization, etc., all the parts of a component that could be shared across multiple design systems. It uses state from the state hook in order to implement this behavior and returns a set of platform-specific props, for example, DOM props, that you can spread onto the elements that you render. So at the top is the component, which lives in your own design system and composes all of these pieces together. It provides the theme and design system specific logic and renders the actual platform elements. It applies styles, which could be implemented however you like, for example, classes or CSS and JavaScript. It uses props returned from the behavior hook and state from the state hook. This allows complete control over the rendering of the element, including things like adding extra elements as needed for layout or styling control. So in terms of our own implementation of this architecture, it looks like this. We have 3 NPM scopes and publish individually versioned packages for each component. React Stately implements the state management, REACT-ARIA implements behavior and accessibility for the web, and React Spectrum is our design system that puts all this together and implements our styling. So let's focus on REACT-ARIA. I'd like to cover 3 areas: the work we've done on implementing high-quality interactions across devices, accessibility and behavior for components as defined by ARIA, and then go through an example of how you'd use our hooks to build your own component from scratch. First, let's talk about interactions. As I discussed earlier, there are a lot of things to consider when designing adaptive UIs that work across many types of devices. You've got mouse, touch, keyboard, and screen readers to consider, and then there's different browsers and operating systems on top of that. The web doesn't have any high-level abstraction over these differences, so we've built a collection of hooks that do this and normalize all the behavioral differences for you. This includes support for high-level events like press, hover, focus, and others. Some of these might seem simple at first, but you'd be surprised how complicated it is to handle these events in a cross-browser, cross-device way. There's a lot of tiny behavioral differences that have a big impact on how well components work across all these platforms. As an example, let's look at press interactions. As you might expect, a press is a mouse click or touch tap. But we also need to account for keyboard users who expect to be able to press things with the enter or space keys. And there's also screen readers and other assistive technology which can trigger presses in other ways. So how do we deal with all this? It turns out the simple on-click event, which you might be thinking of, doesn't quite work the right way across all devices. For one, it was originally designed for mouse events, and touch events attempt to emulate their behavior. There are all kinds of delays in place by mobile browsers to handle gestures like double tap to zoom and such, and these can have a big impact on how emulated mouse events are dispatched to JavaScript. So instead, we use the new pointer event spec where available, with fallbacks on older devices to mouse and touch events. There's also differences in focus behavior between browsers and platforms. Some browsers focus elements when you mouse down or start touching an element. Some do so when you release your press, and still others do it asynchronously. This can have devastating effects down the road on things like focus restoration from dialogues and other overlays. So we normalize this behavior so it works the same way across all browsers and platforms. There's also other details to consider on touch devices like native gestures for text selection. Even if you disable text selection for an element with CSS, the browser still might try to select something nearby. You don't really want text selection to start when pressing a button typically, so we handled disabling text selection when you tap down on a target and restore it when you release your touch. Another detail is scroll gestures. You might put your finger down on a button and then start scrolling the page. When you release your finger, you wouldn't want the button to trigger a press event because you actually meant to scroll. So we handled this and canceled press interactions when the user starts scrolling. And there are a lot of other cross-browser inconsistencies too. After testing across a wide variety of devices and platforms, it turns out that the simple press event was surprisingly complicated to get right. So all of this is handled by the use press hook in REACT-ARIA, so you don't need to worry about it, and our other interaction hooks are the same way. So moving up one level from interactions, we have ARIA. For those who don't know, ARIA is a W3C standard that specifies semantics for many common UI controls so that assistive technology like screen readers can make sense of the div soup that we use to implement these components. But ARIA is just a contract. Since it only specifies semantics, it's up to the developer to implement all of the behavior on top of this with JavaScript. And this is the hard part. So there's an additional document published by the W3C called the Why ARIA Authoring Practices, which provides patterns and examples for implementing this behavior on top of ARIA. They typically specify keyboard interactions that are expected by users of these controls, along with the required roles and states that make them accessible to assistive technology. Adobe has invested a lot into accessibility, and we're really lucky to have James Nerthen on our team, who's the co-chair of the ARIA working group, along with many other accessibility experts. So to help give back to the wider community and make this easier to implement, REACT-ARIA provides React hooks for each ARIA pattern, which provide both the semantics and the behavior together. This way, you can simply spread the props that it returns onto the elements that you'd normally render to implement these common UI patterns and get accessibility and behavior pretty much for free. All you need to do is provide the rendering and styling. We have lots of these patterns implemented so far, and many more are coming soon. For example, we have common form controls like checkboxes, switches, radios, buttons, and text fields, and more complicated ones like selects and combo boxes. Some of these have native browser equivalents, but those can be really hard to style, as I mentioned earlier, so many people end up re-implementing them. And this is where ARIA comes in. It allows you to do that in an accessible way rather than just providing div soups, and provides semantics to those divs. REACT-ARIA provides hooks to make this even easier by giving you a lot of the behavior for free as well as the semantics. We've also got navigation and action components like buttons, links, breadcrumbs, and button groups, and status components like progress bars and meters. Overlays like dialogues, popovers, tooltips, and menus are quite challenging to get right, as many of you will be aware. In order to make these more accessible to keyboard and screen reader users, you need to do a lot of work to contain focus within the dialogue so it can't go outside, and allow the dialogue to be dismissed easily by screen reader users, handle restoring focus back to the trigger that opened the dialogue when it's closed, and more. So REACT-ARIA has hooks for all of this too. There's also many components that could be considered collections. These components display a collection of items and provide functionality like keyboard navigation with the arrow keys, selection of items, and other things. Examples include lists, menus, selects, combo boxes, grids, and data tables, and trees. So we've worked really hard on these components in particular. One interesting thing is that we have a unified API for defining the data for these collection components. And that lets us reuse the same implementation of focus management and keyboard navigation, selection, and virtualized scrolling across all of these components. We also support things like async loading of data, sections or groups in the collection, and disabled items. Of course, many of these features are opt-in as well, and implemented as separate hooks, so it's really composable and you can only include the features you need in your app. All this is super difficult to get right, especially in an accessible way. Virtualized scrolling in particular was a challenge for us due to focus management when items are removed from the DOM as you scroll. So we're really excited to share all of this with the community and hope that it helps make these types of components much easier to build and more accessible for everybody. All right, so let's go through an example of what it looks like to actually build a component with REACT-ARIA and React Stately. If you're integrating with Adobe software, you might want to use our components in React Spectrum directly, but chances are you want to build your own design system, so REACT-ARIA might make sense for you. We're going to build a simple switch component. This is something that doesn't exist natively in a browser. The checkbox is kind of close, but not quite the same thing visually or semantically, so we need to build it from scratch. We start by importing useToggleState from ReactStately and useSwitch from REACT-ARIA. In our component, we pass the props to useToggleState and the props and the state to useSwitch. We're going to use a hidden input element to handle the events and semantics for us, and useSwitch returns the props to spread onto that element. We don't want it to appear visually, so we can import the visually hidden component from ReACT-ARIA and render it inside. As its name suggests, this makes the input element hidden visually, but still accessible to screen readers. We've also added a label element around the input and the text label. Right now, it won't look like much since the checkbox is hidden, so we need to add the visuals that make up the switch. I'm going to use SVG to build the switch in this example, but you could build it however you like. You have complete control over the DOM structure that you render. Here, there's a rounded rectangle for the switch container and a circle for the handle. If it's selected as returned from the state hook, the switch becomes orange and the handle moves to the right. So after that, it'll look something like shown on the screen. There's also one more important feature for accessibility that we need to add, and that's a focus ring. This allows keyboard users to know which element is focused as they move around the app. It should only come up when navigating with the keyboard so as not to distract mouse and touchscreen users. This can be done with the Use Focus Ring hook from ReACT-ARIA. It returns whether keyboard focus should be visible, along with some extra props that we need to add to the input to handle focus events. To draw the actual focus ring, we add an extra round rectangle around the outside of the switch to draw the border. Now, when you tab to the switch with the keyboard, you'll see a focus ring around it like this. So that's a really simple example of what building a fully accessible component looks like with ReACT-ARIA. It provides the accessibility, interactions, and state management for many common components and lets you focus on the part that's unique to your design system, your design. You get complete rendering and styling control since you are in charge of the DOM nodes you render. Just take the event handlers and ARIA props that we give you and spread them onto the appropriate elements, and you get most of the behavior and accessibility for free with a tiny amount of code on your part. We're also focused on providing really great documentation for all of this, showing how to use these hooks to build your own component library for your own design system. That includes lots of examples of using the hooks together, along with clear documentation on exactly what each hook provides that you'd otherwise need to build yourself for full accessibility support and high quality interactions. So we're really excited to announce that all this will be open source by the end of this month. We've got quite a few components already, as you saw earlier, but many more are coming soon. In addition, React Spectrum, our design system, will also be open source. If you're integrating with Adobe products, this is a great way to make your UI consistent, but it's also a really great example of how to use ReACT-ARIA to build your own design system from scratch. We're really excited to work with the community to help improve the accessibility of React apps and the web in general, and hope that our work can help shine a light on how challenging it can be to build native quality experiences on the web. So that's all I have. If you want, you can follow me on Twitter for updates, and I'll be sure to post our announcement when we open source all this. Thanks a lot for listening.
Yeah, Devon, what is it like to have created such an amazing library?
Well, we're going to find out. I'm excited to see who uses it and get feedback from everybody.
Yeah, it seems that anything you would build with this could easily be wrapped using like an adaptive pattern. So I would assume you could easily use this with libraries like Final Forms, stuff like that. Have you guys tested it with anything like that?
So they're just hooks. So you can use them with pretty much anything that you want really easily. So you should be able to use it with the kind of any state management or any other kind of libraries out there. So you really be used as a base for an existing, or maybe not a base, but it could easily be used with any design system. Right.
Someone asked, I have an image with some overlay buttons to edit, crop, or remove it. I'm wondering how accessibility should work here, similar to a select box. I'm not sure if that's something you can easily answer.
I would say probably some kind of a toolbar for the buttons. So like you could use your keyboard to navigate between the buttons, like the arrow keys kind of thing. But in general, like I'm not personally an accessibility expert. So in general, I defer to the experts that we work with here to help us with those things. So
yeah, I assume you guys have a fairly large team working on this there. I was kind of looking for other people's questions and trying to come up with some of my own, but did you say specifically how long it would be until these open source would be made available to the public?
Yeah, our goal is end of month. I was really hoping to have it like today, basically, but
Sure.
things run behind. So we're just finishing up the docs and a couple more components right now. But yeah, a couple weeks or so.
Yeah. So we've had a lot of comments just saying awesome, great talk, a lot of useful features packed into these packages, which I totally agree with. Another question we had was, do you have any idea of how many people use mobile screen reader? And they say, I'm not asking to know how many people to dismiss, but more how can they use the web in general, as they must be discouraged lots of times. And again, you said you're not really an accessibility expert, but
yeah, I mean, I've learned a lot having worked on this for the past few years, though. So I imagine there's quite a few people that use screen readers on mobile, but I don't have an exact number or anything like that, or any kind of detail there. But yeah, you typically use it by swiping around on the screen, so it kind of overlays the entire screen when you're using your phone, right? So rather than using touch to directly scroll the page or to tap on buttons directly, you kind of use gestures to move this like virtual cursor around the screen, as you kind of saw in that demo that I had. So you swipe left and right to move between things, and there's other gestures like double tap to like click on something and things like that. So
I have a question. You mentioned at the beginning that this should be part of the platform ideally, and that it's not the case. I know that there are some efforts on the Chrome team to build this kind of accessibility in the platform. Are you talking to them? I know that Adobe has contributed to Chrome yourself, so do you know anything about it?
We haven't had any direct conversations yet, but I'd love to. So a lot of this is, all of this is a lot of code for sure. So by building it into the platform, it would allow us to ship less JavaScript for all of this, pretty much. Like that's the benefit there. So I'm definitely looking forward to like the platform having more features like that to make it easier.
Google advocates, they always say that we ship too much JavaScript, but you say that the platform is lacking so much that we are forced to ship JavaScript if you want good accessibility. Is that right?
Yeah, it's a trade-off, right? So if you want to implement like these type of components, like where you're re-implementing a lot of things that the browser offers, right? Like I showed that select example. There is a select built into the browser, but people want to style it, and because you can't, you end up having to ship all this JavaScript, right? So I'm hoping maybe one day that browsers will have a way to either style that control or provide kind of lower level primitives for these type of things. And of course, in that case, there is a browser equivalent, but there's a lot of components out there that really there isn't a browser equivalent for. I mentioned like things like data tables. Like we have the table tag, but there's no interactivity in that, or it doesn't have virtual scrolling or all these kind of features that people expect from data tables. So we end up having to build all that with JavaScript. I imagine it's going to be a long time before all of this makes its way into the platform. But in the meantime, at least there is a way we can build things like that.
A few questions. How can we make sure that we're able to be notified when this launches?
Follow me on Twitter.
Okay, we'll follow you definitely. So go follow him on Twitter, everyone. Good question here, and I'm going to follow this up with a kind of well, let me just ask a question. How can this be used in other frameworks? Do you have any recommended patterns for using this with Angular? I assume that React hooks has made this very easy to kind of be the first place that you guys release this code, but could it be used with Angular in the future? Do you have plans for that? Or other frameworks?
No direct plans yet, but I'm interested in seeing if it's possible. Hooks are kind of an enabling technology for all of this.
Yes.
I've been thinking about this kind of behavioral sharing for a long time, and when hooks were announced, I was like, okay, I can finally actually build the library that I want to build. I know that there are some other libraries like Preact, or I think there's like a web components framework that kind of uses, that can use hooks and shim that API. And so that would definitely be one. We're definitely looking into Preact as an option there.
I've also heard that Vue has something similar to hooks in it, that maybe that could be a potential framework that could use something like this, or someone could easily port it over to you to use it there.
Yeah, we're using React for most of our apps, so that was the first priority. But I'd love to work with the community to try to take this code and make it more portable.
Sure. Do you have any information on kind of the bundle sizes for including these two libraries?
So each component is a separate library, or so there's like separate packages for each component.
Sure.
So you kind of only include the things that you need. And even when you get down to the individual component level, like the select or like a table level, like you get to decide, like those components are often split into several hooks. It's pretty low level API. So it's definitely something that you would want to use in your component, like a higher level component library. But the cool thing is you can just include the hooks that you want and get the behavior for those particular things, and not include a bunch of other stuff that you don't want in your app.
Yep. Very good.
Let me just have a question. Have you been talking with the folks from Gatsby, because they are working on a UI framework also, I think, and I think they were reaching out a few months ago.
Yeah, we actually have been talking to them a little bit. Nothing to share there yet, but I'm excited to work with them.
So there could be something coming.
Maybe. We'll see.
This is a question that I can't really think of an answer for, but what about the ESLint rule, React JSX props no spreading? How can we deal with that? There is a is there documentation to know each prop name?
Yeah, so for the ESLint thing, I guess don't use that rule. I'm not sure what the point of that rule is. I've not actually seen that before, so it's the first I'm hearing it.
Usually those things you can opt out of by putting a comment above the line or something.
Yeah. For the docs, yeah, we're gonna have a pretty complete doc site that shows examples of all the components or all the hooks in use and all that, and it's gonna have like all the props listed on there for each of, like, the whole API for all the hooks and like different examples and stuff like that. So hopefully this will answer that question.